G'day, John here again. Welcome to another PyProx tutorial, helping you understand the impact of uncertainty in data and simulation. In the next few minutes, I'm going to teach you how to use control variate Monte Carlo quadrature to compute statistics quantifying uncertainty in the predictions of a computationally expensive model. And I'm going to do that by using that high fidelity model alongside an ensemble of cheaper, less accurate models that have known statistics. In this tutorial, I'll build upon the previous tutorial that introduced control variate Monte Carlo using a single low fidelity model and show how to build control variate Monte Carlo estimators for an arbitrary number of low fidelity models. I will also teach you how to compute the mean squared error, or MSE, of these control variate estimators that use many models. To estimate a statistic Q, we start with a high fidelity model F0 that maps a random variable to a scalar and a set, in this case, of m low fidelity models that approximate the high fidelity model. Like in the two model case, we must be able to extract the exact statistic from these low fidelity models. Also, similar to the single low fidelity model case, we can construct control variate estimators with multiple low fidelity models using a simple four-step procedure. 1. Randomly draw samples from the joint density of the random variable C. 2. Evaluate the high fidelity model at each sample. 3. Evaluate each of the low fidelity models at the same set of samples. And 4. Compute the control variate estimator shown at the bottom of the slide. The CV estimator consists of a high fidelity estimate of the statistic Q0 using the sample Z0 plus the weighted sum of corrections that depend on low fidelity estimates of the statistic Q computed using the samples Z0 and the exact value of the statistic obtained from each of the low fidelity models. Typically, it's easy to write the control variate estimator in vector form, which is now shown at the bottom of the slide. Here, eta is a vector of control variate weights and delta is a vector of low fidelity corrections. Using this vector notation, the optimal control variate weights and the optimal variance take a form similar to that found using the single low fidelity control variate estimator introduced in a previous tutorial. However, now the first term of the optimal control variate weights is no longer a scalar but rather a vector containing the correlations of each low fidelity estimator with a high fidelity model, and the second term is a matrix containing the correlations between each low fidelity correction delta. I'll leave the derivation of these expressions as an exercise for the viewer. Well, control variate Monte Carlo can be used to estimate any statistic, for example variance, with any number of models. This slide provides the expressions needed to construct the control variate Monte Carlo estimator of a mean using only 3 models. Again, like the single low fidelity model case, the variance of the control variate estimator of a mean depends on the correlation between models. However, now the cost of constructing the CV estimator increases with the number of models for a fixed n. Thus, it is problem dependent whether using a single low fidelity or multiple low fidelity models is better. So, one should compute the variance of each control variate estimator for all possible subsets of models using the optimization problem on the bottom of the slide to determine which subset of models gives the smallest variance for a fixed cost. Enumerating all such options requires estimates of model covariance using a pilot study, but you can find details about how to conduct a pilot study in another tutorial. So that brings me again to the end of another PyProx tutorial. Hopefully you now know how to construct CV estimators with multiple low fidelity models. And to realize that simply adding more for low fidelity models is not always better. The relative performance of control variate estimators depends on the correlation between the models and their relative costs. Finally, I hope that you understand that we can only use control variate Monte Carlo with one low fidelity model or multiple low fidelity models when each of those low fidelity models has a known target statistic. You can learn more about other Monte Carlo estimators that do not have this restriction in future tutorials. See you next time.